Going to wait to see if it's running. Today I'm going to study some templates that I found from this guy here. Highly recommend his channel. There's a lot of useful information from the videos I've watched so far. And I found that this is the repository where he puts this all the stuff that he talks about on the videos. And then there's these 3 different repositories that I cloned. And I'm going to be looking into the code today. I couldn't figure out the error that I was getting from last stream, so maybe I'll try to figure that out as well. Obviously, I already thought about this solution on the last time that I streamed, to just download the code and put the files there, but it's not the best solution. So it's kind of annoying because I don't know really well what's going on, like why it wasn't working. So, and the issue, like there's 2 issues that I'm getting. One is that it's saying that the function definition can find the declaration or vice versa, one of the functions. And the other error is that one of the packages, it seems like it is not downloading the package. Is downloading the package. I'm trying to use Conan to download, but it seems like one of the header files from the project is not being accessed, and I'm not really sure what to do about it. I'm just gonna wait to see if it's streaming because it's not showing here on the channel. Yeah, last time that I streamed, I was having some problems with the internet, so I was kind of slow and cutting off. So I'm gonna wait to see if anything is showing. Maybe I'll try to restart the stream if it doesn't show anything. Or I will just record for myself and then I'll upload the video later. Not sure exactly what is going on. Maybe it's the internet that has been bad these days. So I'm gonna wait a little bit more, and if it doesn't show, I'm just gonna continue and then I'll update later if it's not live. So it looks like it's not showing. Maybe if I go into the live thing. Now on the live page, it seems like it is streaming, so but it's not showing on the channel. Maybe they changed something on YouTube. It's whatever. I'm gonna do it. There's a lot of stuff that I have to study, so I'm probably not gonna stream that much these days. There's 2 different courses that I have to do now, and there's a bunch of different videos, and I still have to finish the books. I'm leaving the books to finish later because I want to study more C++. And also I found that there is like 100 different, from Jason's videos, he shares, I think it's this one, like the main topics to be an expert as C++, and it's a lot of stuff, so it's kind of discouraging. So I'm gonna spend a bunch of time studying all these things. And obviously to really know them, I have to actually try to build stuff, because just by watching the videos, you're gonna get into tutorial hell. But I'm trying to speed run the tutorial hell phase for me, and then try to build stuff simultaneously. So these are the notes that I took so far. I watched a bunch of videos on the review topics that I had, but I'm planning on watching or going one by one, and then usually the way that I'm doing now is just put the topic here, and then I open several different videos from a bunch of people to watch. Luckily, there's a bunch of videos from C++ from several different people, so yeah. And then each topic I just watch, and then I'm gonna mark as blue the ones that I went over. But there's like around 100 topics here to study, so there's a lot of things. So this is one thing that he says, is that you should always prefer to use the pre-increment. So the difference between the 2 is the pre-increment increments the value and then returns the value, and the post-increment uh, returns the previous value, increments the value, but returns the previous one. So this one he doesn't recommend you use that often. Then there's two different functions to push items into a vac. And from what he says, I think he recommends this a little bit more, but there is not that much difference between the two. This one creates a new object, and then this one uses the same object. And this was something that I didn't see in the books a lot as well. That there's two different types of constructors in C++. One is the copy, and the other one is the move. And the main difference between them is just the reference. So in the copy constructor, you just pass the argument as a reference. And on the move constructor, you pass as a reference to a reference. And there's a fundamental difference between right-hand side values and left-hand side values. Right-hand side are values that are data, and left-hand side are values that are places in memory. So that's the biggest difference between the two. Usually the left-hand side is going to be on the left, obviously, and the right-hand side is going to be on the right. But there are some situations where you can have an address or data on the right, the left, the data on the left. So the right-hand side is not always going to be on the right. The left is not always going to be on the left. But usually that's the way it goes. And the difference between them is the references, I think. So you can't assign a value to a right-hand side or something. Yeah, I think you can't assign a new value to a right-hand side because it's just data. It's like you have a number 42, for example. That's a right-hand side value because it's just the data. So if you try to assign that to a new value, it's going to give you an error like this because it's not a place in memory. But usually the way that the reason why this is used is because you have a move constructor, and the point of the move constructor is that every time you create a class on C++ and you assign the class to a new value, to a new variable, what's going to happen is that the C++ is going to automatically call the copy constructor, which is the one that has one reference, and it's just going to create a new place in memory and copy all the values from the class into the new variable. But if you want to avoid that from happening, what you have to do is just specify the move constructor. And what the move constructor is going to do is just going to update the pointer. So it doesn't create a new value in memory. It's just going to make it so that the variable that you're creating is pointing to that value that already existed. Then one example that they talk about in the video is when you have a function that returns a string. So usually in that case, you would copy the value twice. One when you're creating the string and the other when you're assigning to the variable. But in order to avoid that, you should return this double reference or the R reference, because if you do that, it only creates the string once, and then it makes the variable that you're making it to equal to the function point to the value that was already created instead of creating a new one and then pointing to that one. So it saves a little bit of memory and time, I think. But it's very confusing. So it's going to take me a lot of time to understand exactly how it works. Lambdas have const arguments by default. In order to change them, you have to put the mutable keyword before calling them. So lambda function is just when you have like this thing here. I don't remember exactly how you write, but maybe the name is here. I think is, yeah, you put the name here and then you do like a normal function. Or no, actually you don't put the name. I think you just put this pattern here, and then if you receive arguments, you put like it's A here, for example, and then return A, something like that. I don't remember the syntax very well, but it's just what I do remember is that it starts with the square brackets. So that's, and based on what Jason recommends, he says that if you understand most things about, from what I remember, says that if you understand most things about lambda, then you're gonna understand most things on C++, because lambdas have a lot of complexity and variance on them. So variadic templates are like the spread operator in JavaScript, but for templates. So just when you put the 3 dots, when you have a template and then you put the 3 dots before usually they write it like right next to, that's the difference between JavaScript, is that they write right next to the thing, but I think it's the same thing. In JavaScript, you usually write next to the variable. But when you have a template like this, it just means that you're gonna have an arbitrary numbers of values. So this is like the same as using the asterisk in Python as well, when you pass an argument to a function, just so you can declare an arbitrary number of values. But I think this is usually done for templates. from the codes of the project that I was studying, I think that they use that as well in some other place. But it's just the same as JavaScript, so yeah, the standard move is the thing that I was talking about. Is the same pattern as you use on the constructor, but it is for more like generic applications. So when you want to pass a variable to a function, to a normal function or something like that, you can use this function, which is going to do the same thing as I said before. Instead of creating a new value, a copy just moves the existing one, moves the ownership of the variable. Yes, instead of copying our value, create a new place in memory, creates a reference to the R value, or the temporary values, data, L values, R addresses, memory. The true ampersand allows to create a reference to an R value. For example, when returning a string from a function, it's better to these are values, stuff that I talked about. Move constructor. This I'm not 100% sure. I don't remember very well, but from what I remember, the move constructor creates a shallow copy, and copy constructor creates a deep copy. And the difference between the two is like when you have a nested object, for example, when you do a shallow copy, it only copies the surface layer of the object. When you have a deep copy, it's going to copy everything from the object. So in JavaScript is when you usually use the spread operator when you have a nested object in order to like copy paste the previous one, all the values, and then add the additional ones or change whatever you want. So you have to explicitly tell, and then usually you have libraries that do that for you if you want a deep copy. And usually that happens when you're trying to update states on JavaScript. But yeah. And this stuff is kind of confusing to me, but it pretty much, they say that if you have namespaces on C++, it's not always that you have to explicitly say the namespace. So usually when you have, for example, the namespace of standard library, it allows you to declare variables that have the same name as the global space, for example, because you're encapsulating them on another scope. And then the way you usually access those variables is by specifying the namespace from which they are from and then specifying the name of the variable. But based on this dynamic here you have on the compiler, sometimes in such situations, it's going to automatically look for the closest value of the variable that the variable can be referenced to without you explicitly saying where it comes from. It's kind of like it resolves automatically for you. But there are some nuances and I'm not really sure about it, so I have to study more to understand. I think that's pretty much all that I've learned so far. And now I'm trying to see if I can solve the problem that I was having on the other one, like try to understand exactly what is going on. So maybe I should open I don't remember if I have here. Should open the project again and show. But pretty much what I'm running into is I'm trying to use Conan to install a bunch of external packages on this project that I'm trying to study. And I'm getting through errors. I was getting through errors. One is that it isn't finding one of these header files here. I think it's this one and this one. That they come from this library here. So it seems that it can access this header file from the main library, but it doesn't find these other ones. And if I remove them, then it gives me other errors because some of the functions that they are using here come directly from these header files here. So I don't understand why Conan doesn't get them. And my intuition says that it's something to do with the way that the CMake files are set up, but it's not clear to me. And the other error that I'm getting is that on this project here, he declares this namespace OpenGL, and then he declares this function inside this program struct here, which I think is this one. And then he defines the function right on this file here, the same header file. But then the compiler is saying that it can't find it's saying that there are multiple definitions for this function. But as far as I can tell, there's only this one. So I don't really understand why that's happening. I think that the reason might be because this project uses an external library, which is the OpenGL library. So I think that there is some conflict because it is declaring the namespace with the same name from the OpenGL, from the external library. And I'm changed the way that I am trying to do things from the way that he was doing. And because of that, I think that this is what's happening. It's like something on the CMake files. I'm probably using the thing is I tried to change a bunch of ways to use these specifications here. What the specifications mean on CMake is pretty much that it's which places are going to have access to the values you're declaring here. So if you declare as private, then anything that depends on these things here are not going to be able to access them. So if you want other libraries to have access to whatever directories you are including with this one here, you have to set this as public. So public and private, and I think interface is the other one. It's just different ways to declare which packages are gonna have variables are gonna have access to which headers from which projects, and it gets very confusing. But I tried multiple different variations of this, and it's still having the problem there. So I'm not exactly sure what's going on. Maybe I'll try to. Thing is, I don't remember which one. I think it was this one, maybe. I'll try to run again to show the mistakes that I'm getting. I think it is this one. And so the first one you have to run, and this is another thing that's is like getting more clear to me, is that like you have to run build twice with CMake if you're not using the Unix makefile generators. So when you use CMake, you can use several different generators, and the generators are just the different compilers you can use. And depending on which operational system you're using, the compiler is gonna be different, because the resulting code is different because of the instruction set architecture. So every operational system has standards of communicating with the hardware, and then each hardware is going to be different, I think. So the hardware is the thing that directly encodes the machine code into the main instructions, which are the assembly instructions, which is going to be a result of combinatorial logic. So like people set up a bunch of ones and zeros on the hardware, and then based on that, they decide based on combinatorial logic that those specific sequences of zeros and ones are going to be an instruction. And those zeros and ones are going to dictate the coordination of different parts of the hardware to change memory, to change the state of the hardware. And that's what all this happening, I think, is in computing. You have registers, you have forgot exactly the ALU, arithmetic logic unit, the thing that does the math. Then you have the RAM, which is going to contain the addresses. Then you're going to have the program counter, which is the stuff that runs the program and keeps track of everything. And then based on the mathematical result of the ALU, the arithmetic logic unit, you can encode information you pretty much connect the ALU with other registers, registers are just like RAM, but they take less memory. So you connect the registers with the ALU, and then based on that, you can encode jump instructions, which are going to make the thing move to a different label in memory. So all that's happening is that you're encoding a bunch of zeros and ones into the coordination of what happens in memory in the computer, which is going to be a result of calculations. And then based on that, you create standards, and then based on the standards, you're going to have the assembly instructions. I think that the instruction set architecture is set up by the hardware manufacturer, but I'm not 100% sure. And then based on that, the first program that you have on any computer is going to be the operational system, which is the thing that decides what's going to be the logic for managing resources and creating different users, different protections, different instructions to access the hardware and to communicate with the network, which is going to be another program as well. And then based on that, the programming language is going to be the thing that communicates with the operating system, which communicates with the hardware. And the compilation process is about transforming deterministic or non-deterministic finite automata, which is just a way to say that you have a graph that represents the changes in state of strings. So you have one string that's a massive input. Then from that string, you're going to parse that into rules that you call grammar. And then based on those rules, you're going to create a graph structure that is the relationship between the states of the string being parsed through the rules to create a series of lower level instructions, which is going to be the standard of the operational system, which is the interface, which is the assembly instructions. So you're just taking a higher level abstraction, reducing that into assembly instructions by applying sequences of rules into inputs, which are strings. And then based on that, those assembly instructions are going to be the calculations on the hardware. So I forgot why I was saying that. I completely forgot why I was saying that. Maybe it was something to do with CMake, but I forgot. But basically on CMake, you're gonna always run these two different programs. The first one, you're gonna build everything. So it creates the object files from the code, I think, the C. And then after, I'm not really sure exactly at what point does it create the connections. So the first step is to create object files from the code, which is gonna be just the parsing of everything, all the functions into lower level instructions. And then from that, it's gonna do the linking process, which is gonna be to take all the object files and create a graph of dependencies. And then from that, it's gonna create the executable. So I think that this is the reason why I have two steps here on CMake, but I'm not 100% sure. So I think the first step, it creates the object files and the lower level instructions. And then on the second step, which is the build phase, you create the linking process. And then from the linking process, the executable is created. So depending on which kind of generator, I think that's what I was going to say. Depending on which kind of generator and what kind of operation system you have, the process of creating the linking is going to be different. So if you're using make files, it's going to first create the make on CMake, and then you run the make command, and then that creates the linking and the executable. But if you're using the MSVC, the Visual Studio compiler, I think it uses MS build. Then first it's going to create this VC package files, and then so the VC package files are like the equivalent of this VCX proj, are the equivalent of the make file, as far as I understand now. So they contain XML that contains instructions for creating the linking process. So you run this command, and then you have to run the other command to create the actual executable. But it's pretty much the same pattern. It's just that the only difference is that this creates this kind of file, and the Unix make file creates the make file, and then you build the executable from that. But here I'm getting, like, this error that I'm getting, I understand. I was getting another error that I fixed by just putting the files here. But obviously this is not the best because I want to understand what's going on under the hood. So maybe I'll delete this just to show. But this comes from the GitHub project that I manually download the files, put the header files here, and now that they are working. So the way that you specify in CMake where the header files are just by putting this stuff here. And then the specified here is going to go into the stuff that I was talking about, that it's private, the external libraries don't have access to the header files here. If I want the external libraries to have access, then I put it in public. But I think that doesn't make a lot of sense because, like, by definition, since it's an external library, it wouldn't make a lot of sense that it depends on header files that you have on your own project. So I think usually it's going to be the case that you're going to use private here, but I'm not 100% sure. But you have to manually specify it. I'm not really sure if it accepts wildcards here. I haven't tested. But from what I know, so from what I know now, it seems that you have to specify each level of the directory that you want to include. And here, for some reason, I think that these ones are not working. This one, but this one is. So I basically just manually included the files because the download from. I think that when I download the file from Conan, something is going on that I don't understand very well, and it's not being able to access the header files at the other directories of the project, which is this IMGiri or something like that. And I tested multiple different variations of this private and public, and it's still the same thing, so I'm not 100% sure what's going on. But after I did this, then it's giving me this error because I copied the code from the other project and I put on a different level here. This code is from a class on the other project, and the other class inherits from another one, and the other one has access to this window object here. So that's pretty much why I'm getting the error now. But I think I'm gonna exclude, or I'm gonna delete this one to show the error that I was getting before. And I thought about this solution last time in the stream, but I think it's not very, like, I want to know, like, at the fundamental level, what's the problem that I'm getting into here. because I think that's what matters. So I don't, because I'm probably gonna keep getting into the same error until I figure out how it works under the hood, which is kind of the annoying thing about this, and it's kind of frustrating because there's a lot going to understand what Conan is doing under the hood and how everything works under the hood. The other error that I'm getting into is this error here. That's this is the function that I was talking about, comes from the OpenGL namespace, then this program struct, and saying that's unable to match the function definition to an existing declaration. So the only thing that makes sense to me is that is declaring the function twice, but I don't understand how. Like, is declaring the function twice and then the definition is one time. So when you declare the function, you're just like specifying this is the declaration, just specifying how the structure of the function, what kind of arguments it takes, and what it returns. And here is the definition. And I think when you use static on C++, it just means global variable. At the first step of the compilation, they're not going to be aware of each other. So if you don't declare as static, there's no way for other files on the project should know that this is available. So static is just a way to make available to all the files, I think. So just at least the way that I look at it is just saying global variable. So I think that, but I try to remove this and it still doesn't work. That's the issue. Because the main thing that I think is going on here is that this is supposed to be another GitHub project that the other project was using, but I tried to merge the two. And this project here uses an external library, which is OpenGL, I think. And because of that, I think when I'm installing here the OpenGL external library, then it's getting a conflict because they both have the same namespace. So the function is being declared on this one, but it's also being declared on the current project here. But I'm not 100% sure if that's the problem. So like when it tries to find to link the definition with the declaration, it doesn't know if it should link with this one or if it should link with the original. But so maybe one thing that I can do is just search for OpenGL and then this function here, to see if that's the case or not. So after I do this, what I'm gonna do is just look at the repositories that I cloned from JSON. They are showing the templates that he recommends to start a project with Conan, or with if you want to do a GUI project or just a standard template. So I want to look into them to see what he recommends to put on the CMake files. And CMake is the thing that you compile, and Conan is the thing that it's kind of like pip in Python and Yarn in JavaScript. It's just a program that manually or that automatically fetches the dependencies for you and then caches them and all that stuff. I'm gonna search for OpenGL documentation, see if I can find the code on GitHub, and then see if I can find the function on the project to see if the library is supposed to have this function. Or maybe I can look into the repository that I cloned from the other guy, because he puts a link to the OpenGL. I think it's this one. And this is a project that I'm trying to make it work. But the only difference is that I downloaded these two libraries here, and then I'm trying to merge them into the main project instead of putting them as external dependencies for this one. Because I think it's easier, or it's better to think about it this way, because then I separate the codes from the external libraries. But I think this is the problem here, because these Like this is the library that requires. But the thing is that like what makes me think that is not the problem is because it wouldn't work with this project because like they're saying it's not like they were separated. Like the dependency for OpenGL was from this one, and then the project was using OpenGL, and then it creates a conflict. It's like the OpenGL is a dependency on this one. So if the problem was that there are two different instances, one from OpenGL, the external library, and one from this project, then I think this project wouldn't be the way that it is now. But I'm not 100% sure because I don't know the motivations of this person to create this project. So maybe they did it in the wrong way and then they just left like this. So I have no idea. The other thing that is kind of confusing to me now, I think that the way that it works, but I'm not 100% sure, and this is the confusing part, is that the way that you're gonna specify the paths on the C++ files is gonna be from the directory you include on the CMake. I think that's what makes sense to me, because the CMake is the thing that determines the linking process. So then I don't understand very well, like if that's because it could be the problem that I'm uh, importing this the wrong way. So, but I'm not. I think that's probably unlikely because the function that is giving problem is declared and defined on the same file. So yeah, but I think you do have to specify like from the include directory, but I'm not really sure because now I'm including like both uh, all the levels, so I don't really know. The question is like how from what point from what route you should specify the relative path on the when you import here. If it depends on the way that you declare here, this is the thing that is kind of confusing. So I think I tried to remove this and see if it works, but I think it doesn't. Also, I tried so after the first time that you run the CMake build, it creates this cache here. So sometimes I have to delete this if you want to use a new generator, for example. Yeah, now it's showing this problem here, which was the other problem that I was talking about. So for some reason, it can't find this file here. And this file comes from this project here. But I'm downloading this project with Conan, so like I don't I think I tried as well to put like the relative path that it is from this. So I think it comes from backends and then this. But this also doesn't work, I think. But I can try again. So I want to understand exactly what is going on. So why does it download this thing here, but it can't find the file that is part of the project? And it has to do with the way that Conan installs everything and the way you have to specify the files. But I don't understand exactly why. And the other problem is this one with the function definition. So I think I'm gonna delete the cache and then try again. I'm pretty sure I tried a bunch of different variations. I'm kind of lazy to be honest. I don't wanna because the thing is that it's kind of a big project, the other one, so I don't want to change the name of this and then I have to figure out every place that this is being used. So I want to see if I can find an easier way to figure out first. And maybe I don't even figure this out, I just find a way around it, which I'm pretty sure I can do it. I'm probably just gonna start another project from scratch and just try to incrementally build on my own, because it might be better. It's still the same stuff. I think I'm gonna just look into this CMake files here and create another. I was gonna open this other one. I created this repository here. I think I'm gonna, so I'm just gonna figure this out. I'm gonna like watch a bunch of videos and study a bunch of other things, and I'm not really sure if I'm gonna try to go all the way to figure this out here. I think it's probably better to just try to create a project from scratch and then just add this stuff incrementally. So the main thing that I'm trying to accomplish is to create something with a GUI. The problem is that most of the tutorials I saw in the courses that I'm doing, they use like an external library, and then the external library has a program that allows you to generate stuff with the user interface. Like it's kind of like a program where you can build the things by manually using the program, but I don't like that very much. I just want to be able to see if I can just with the code create everything. Because I think that's better. It's more difficult in the beginning probably, but over the long run, I think it's gonna be a lot better if I can do like that. So that's what I'm trying to do now. So I'm probably just gonna create a bunch of different projects and try to. She's using a text file. From what I've seen from the documentation, I think the Python file is more powerful, but the text file is simpler. And then here you specify which libraries, external libraries you wanna use, and then the generator. I still don't understand this one very well. I think it's just like the name says, is the libraries you want to link with your project. So it's probably external libraries that you have that you want to link. So it creates the object files from these projects and then links to your project. And then if you put private, your files are not gonna have access to the other files. I think this is probably done so that you don't have conflict between the names you use, the names of variables. And then here, this is usually the first argument is going to be the name of the project, which I think is the name of the final executable. So you can have multiple executables, I think, as well. So you can have like this, and then you just have to specify for each executable what you need. And then in the final build, you're just going to build two different executables. One is going to be intro.x, the other one intermediate. And then on the other files, you specify for which one it is. But from what I've seen, usually people they put project and then specify the name. I don't remember really well. I think there's other arguments you have to put here, but I don't remember. And then you just use the flag variable, just going project name. It's kind of like JavaScript where you put the flag variables on inside of the curly braces with the thing. This is another thing you have to do. When you use Conan, Conan's gonna generate another CMake file inside of the build. And the first command you have to run is the Conan build command. I'm gonna show there on the other project. And after you run that, it's gonna create a build folder, and then inside of this build folder, there's gonna be a CMake file that is from Conan. Has all the specifications of what things should do. And then you have to include that file, the CMake file. So I have to include this make binary here. I think this is gonna be the build, or whatever one you specify. First command that you run. Install. Then you specify which folder is gonna be. Usually is gonna be build. I think the standard is probably to uh, put everything on the build folder. Then you can specify. I think if you Python file for Conan. You can create the layout you put here. And this layout basically documentation. I didn't use this for now, but I think you can specify it. And you don't have to put the flag variable. It doesn't matter that much. And then after you run this, it creates the build folder, and then it's gonna have the CMake from Conan. I think it's this one. And this one contains all the code to install everything, to set up everything. And it looks like he puts another folder here, configured files, include. So one thing that I can try to do is just run this stuff. But there's also readmes here. But based on this stuff, there isn't much, to be honest. One thing that also I don't understand very well is that sometimes you put, I think it's going to depend on the library. Like in C++, the way you access values from class is by using these two dots here. So I think when they put stuff like this, they're just saying like link all the files that come from this class, from this project. But then the tricky thing is that each project is going to have, there can be cases where the name is different. Like on OpenGL, I think you put OpenGL here and then GL on the other one. So it's kind of confusing. And I'm not really sure, like maybe that's the problem on the other one, that I have to specify like a broader definition. But maybe I should try that. Just put OpenGL without the thing here. Maybe that's... And then you have to put this stuff here as well. So I think this first, like, is gonna run this commands that is gonna call Conan and then run a bunch of code that is gonna install everything on a path. And they share, I think, a command so that you know in what file your Conan is putting everything, is downloading everything into. And then after that, you put the CMake commands there to find the package from Conan, I think. I think it's Conan something. It is on the documentation, but I forgot. Whatever. There is a command that they talk about on the documentation to run, and then it shows the path to where Conan is located. It's usually going to be on Windows, on the user, and then the name of the user, and then .conan something. Mine is Conan 2. So this is where it puts all the files and the profiles. Profiles are the specification of what kind of build you want to run. So I'm using this one for now because the project, I think it requires that one of the libraries required to be on Windows, because I think what the library does is to call a bunch of functions on Windows that creates the window. But then create another one for Linux. And I think if you're doing cross compilation, which is just to create a project for several different kinds of architectures, you have to create several different profiles, and then you specify on the Conan Python file. On the layout, I think you can put logic here that's like if generator or whatever. Like you can logic that's based on which kind of setting, and like this, like this. It's gonna run a different kind of profile. But first, I wanna see if I can fix the other stuff. I'm really only gonna worry about building for Windows, I think, now, because I'm using Windows. Then if I manage to make all of this happen, then I can think about building everything for Linux because I think it just becomes a lot harder if you're doing for several different operation systems. This projects make version. Curious to see the GUI CMake that he creates as well. It looks like it wasn't. Oh, but I changed the name. Maybe if I put another name again. But I think it's not gonna work. This one also. And I think I tried to put here as well. But like logically, it wouldn't make sense to me that this would work because you would just make increase the chances that there is the conflict because now the local libraries are gonna have access to this one. So let's read the readmes. All efforts to maintain blah blah blah. This is C++ best practice. Oh, this is another kind of annoying thing, but like it is recommended to do, but I think I'm not gonna be doing probably. Like he always recommends you to use a bunch of flags that is gonna allow you to for the compiler. And he recommends you do that, but I think it's gonna do like these multiple verbs because there's already stuff to deal with, like the actual code. But maybe I'll change my mind because it's probably better like to find the errors on compilation time than finding the errors on runtime. Because if you don't find on compilation, then it becomes a lot harder to debug, I think. But yeah, I don't know. Like I think another one of those things like just everything else. It's gonna depend on the circumstance, and I think that the positive side of not using this warnings is that it forces you to think more about the project and understanding how everything works. But obviously, it's probably most of the time it's probably better to put the warnings and then solve everything on the foundation. Just I'm lazy, so not really sure if this one. I think it is. There is one that he still maintains. Is this one? I think that the mic is probably cutting off sometimes. There's not nothing I can do about. And these are two different libraries that he also recommends a lot for testing. And testing is another one of those things that usually I don't do. And I haven't found the only time that I felt the need was on when I was building the front end for the thing. And I think that it makes a lot of sense when you have a project that is big because then you want to automate the process of testing everything or to see if something even if you know like all the things that can possibly go wrong, it still increases the chances that you're gonna forget if you don't create the test. So I think for that reason it makes sense, but it takes a lot of time. So I think usually in the beginning it's probably not worth it. Only when you have something that's it's already complex and then you don't wanna risk forgetting something. But it's kind of annoying to be honest to build tests. So I think Ninja is for Unix from one of the videos that I've seen. It's more a compiler for Unix or Linux. But maybe it works on Windows as well. Because the Unix make files or the generator works for Windows as well. If you use Chocolatey to install everything you need, and then you put this stuff on the path by just going here, and then you put some path here. Then the operational system is gonna know about the executables based on the path you provide here. And then if you do that, then you can use make on Windows. And I think it's probably the same with Ninja. And this stuff is recommending to install. Not really sure if I have this one. I think I'm gonna try to install this because I don't remember if I did. And as far as I remember, LLVM stands for low level virtual machine. So it's just the one of the steps of the final steps of the compilation process. So the first you get the string, then you turn that into Lexer tokens, which are gonna be defined in the grammar, the rules of the grammar. So just like words in normal language, that would be like the tokens. So it's just the lowest level of abstraction that it has a meaning on the language, I think. Then the first step is to break the string into all these words, and then the second step is based on the rules of the grammar to put the words together in a way that has meaning, and you do that by creating an abstract syntax tree or create a parse tree first, which is a more complicated tree that specifies the way that the words are gonna be put together to create meaning, which is gonna be dependent on the type of compiler you use or compilation process. But it's usually gonna be done through a recursive function or something like that that creates a tree, and then based on the way you traverse the tree, you're gonna build the sentences in the end. So one step before that, you create the abstract syntax tree, which is the stuff based on the rules of the grammar. Then based on that, you're going to create the intermediate representation of the code, which is just a more generic way to represent the code so that it can be broken down into the different instruction set architectures, which is just different assembly instructions based on which hardware you're using, which operation system. Then based on that, or before you even do that, you create the control flow, which is a graph that contains the control flow of the program. And during those processes, you also have the table that is going to keep track of the symbols and what they mean. So pretty much the variables. Every time you declare a variable, it goes on the symbol table, and then it allows you to keep track of the scope. That happens, I think, on the abstract syntax tree and the token level, and also on the intermediate representation and the binary, which is the end. So from the intermediate representation, I think you create the assembly instructions, and then from the assembly instructions, you call another program, which is the assembler, which is going to convert the assembly instructions into machine code, and then you execute. And I think that most of the variance between the differences in different compilers is going to be on the intermediate representation and then on the control flow graph, because that's where you can do a bunch of optimizations to just replace code and make it faster. And then interpreted languages, I think the main difference is just these nuances on the way that you optimize and you execute. So interpreted languages, you're going to convert and execute right away. And then on compiled languages, you're going to compile first everything to binary, which is creates the executable, and then you run the executable like in different stuff. And I think the low level virtual machine is involved in this step of creating the assembly instructions and in the intermediate representation and into creating the executable. And I think it has to do with threads as well, probably. Like in Python, you have different threads and you have to manage the state of the interpreter. So I think those kinds of things are probably related to this LLVM. So just saying what kind of stuff you need to run everything. And there isn't much, to be honest. There isn't much here that I don't know already, I think. The difficult part about this problem that I'm facing now is that I don't know really well like what direction to go. There's not gonna require me to spend a bunch of hours or a bunch of days trying to refactor all the code from the other project. And the thing is that if I do that, then the problem is that it's just like a trade-off on time. Like maybe it would be would be much better off if I just start everything from the beginning because then like it would make a lot more sense than trying to refactor everything and understand how the project works to see if I can make it can fix these mistakes here. So that's kind of the thing that I'm not really sure about which way to go now. And here on the Python file on the Conan, that's how we specify which kind of external packages you're gonna want to download. And these ones you go to the site. I think I showed this on the last stream. I'm just gonna go again. Just Conan.io, and then they have a page that shows. It's kind of like the crates on Rust. Just a server that contains a bunch of packages. And obviously, the Rust, the crate is gonna be for Rust packages, and here's for C++. So just put the names of the libraries here, and then it finds if it has or not. And this one, I got the source code from GitHub. That's how I fixed the other error, but it's not very good. Let's go here. Then the backends and contains the file. I think you can put the name of the file here as well. Then it's gonna show. I think I'm gonna close this stuff here. All of them. I'm gonna leave the OpenGL one or the GUI open. So maybe I'll try to copy the stuff that he has there. I'm gonna close this one. So I think I'm gonna look into that project and I'm gonna try to put the CMake file. Just gonna copy the whatever he has here. Actually, this one. I'm gonna look into this one first. Then I'm gonna copy the files that are necessary in the beginning and then try to run from the other project, I think. I'm gonna try to create a very simple, the simplest project that I can that has a GUI. I think that I'm not really sure as well is like if there is a specific kind of GUI you need to create in order to run OpenGL. So probably gonna have to spend a bunch of time reading the documentation and trying to figure out, or maybe search for videos as well. But the thing is that it's gonna take a lot of time because I have to watch a bunch of these videos and courses and everything like that. This is 13 hours, this book. And there's also a bunch of videos here that I haven't watched yet. Oh, there's also this compiler he talks about. This is another thing that I'm thinking about doing on stream. So you can put the code here and then you can look at some different versions of outputs here. And there's some other exercises as well that I think that, yeah, I installed a book from him, I think. It has a bunch of exercises that you can do. It's probably a good idea to get better uh, by practicing instead of just watching. The difficult part is to know exactly when to use each thing. Like there's so many concepts that it becomes very confusing when you should use each stuff. So this one is the one that has libraries. Just adds them. This is another thing that I don't understand very well. Like, at what point is is another one of those things because and I think that's fundamentally how space-time works. It's always going to be like this, where you're going to have a polarity, and then from the polarity, you're going to have an infinite distinction between the two, which is going to be a multifractal pattern. And the multifractal pattern is a consequence of the computation of a network that creates geometry, which is space-time. So every boundary is going to be a convergence towards infinity because it doesn't exist. And the change in the boundary in relationship to space is going to be time. And that creates a funnel of information, which is a multifractal, which is a singularity, which is a paradox. So the paradox is the highest approximation of balance because it's the convergence between relative polarities that creates the distinction, which is the geometry, which is a multifractal pattern. So it's just like on Mandelbrot, the multifractal is defined by the distinction of the convergence or divergence of inputs and outputs in relationship to a function. And the collection of multifractals is the essence of spacetime. So here I think it's kind of like the same thing where like it's hard to know when should I create a library here. So like why not put the distinction between external libraries and your code is a lot more clear, obviously, because like they are very decoupled. So like, it makes sense that you separate your own code from external libraries and put them on different folders or whatever. But if you have your own code, at what point should you separate your own code from itself to create like a library instead of putting everything together? So this is the reason why it doesn't make a lot of sense to me for this, but then it's going to be one of those things that based on experience, and that's kind of the problem that I'm trying to solve, because I think it's stupid to rely on experience. You don't need experience if you have data, I think. So instead of spending a bunch of time going through experience to create everything, you can just get the data and then highlight where the boundary is. But I think that's usually the way people learn now. It's just, but based on a bunch of experience, you're gonna learn all the nuances of the game, and then based on that, you're gonna develop intuition of where the multifractal boundary between the two things are, which is gonna be the circumstances of the project. And then based on that, you're gonna be able to decide when you should when you should separate the things. But if you don't have experience, then it's very hard to understand like why exactly should I create different CMakes here instead of putting everything on this one. I don't understand where this support should come from. Oh, it's here. And it's still kind of weird. I don't think is supposed to mean this directory here. It's saying that it's a library, so maybe should be a CMake file somewhere. A simple library, I think, is this one. Maybe, yeah, is the name of the project itself. So whatever the parent directory of the CMake is the name of the library. That's what makes sense to me. So that when it says sample library here, is that referring to this file? And then is adding this stuff here as a library. This is another thing that is kind of weird to me that I don't understand very well so far. That most of the times that from the stuff that I've seen, they put the add executable first, like add executable command here, and then they put the CPP files on this to create the project. So they put the name of the project here, and then it puts the whatever files you have that you want to create the objects on the thing. But they usually put this before they put the target link libraries. So I don't understand very well like how does that work. So it indicates to me that probably like it doesn't execute everything sequential order, or that when it executes this, it doesn't. But like it wouldn't make sense to me, because then how is it possible? Like what if this file depends on some of the libraries here? So how is it gonna know that if it's creating the object file before it links the libraries? But I don't understand. It's very hard to find the information about this, because the documentation is just gonna say like what the thing is and not exactly why it's structured this way. So let me look into the GUI one. I wish that the documentations were more like this. Is it like usually, and I don't understand. I think it's just because of the energy. That's usually how things go. Like people want to do the thing that's easiest because it makes sense. It just outcomes razor. So oftentimes people are gonna create the libraries just telling what the what the functions do. But I don't. It doesn't make a lot of sense to me, because you can just look at the source code usually. So like when you look, usually when you look at the documentation, it just says what the function, like the parameters that it accepts and what returns. Like it doesn't make a lot of sense, because you just look at the source code. So I don't understand very well. Or when the language has types, you can just look at the types. So it would make a lot more sense to me that the documentations explain why the library is done the way that it is, and how is the connection of everything. Like what is happening under the hood, and why should you use each thing. But I think that this is the stuff that I was talking before. Like the reason why it's hard is because it's going to be a multifractal. It's going to be depend on the circumstance. So you just need a lot higher level of complexity to do that, because you would have to. And this is kind of the paradox, because when you create the library, you don't know exactly for all the possible ways that the library is going to be used and what kind of problems are going to arrive from that. So by definition, the evolution, and I think that's related to the essence of space-time, because the evolution of everything is going to be dependent on this paradox. So like everything is dependent on everything else. So you can only create abstractions based on what already exists. So like the past and the future are the same thing. And because of that, the flow of the arrow of time is the illusion that things are always getting more complex, because that's what entropy is. I think you can put whatever name you want here, it's just the name of the executable. It doesn't have to be the name of the project. I don't understand where this spot should come from. Neither this thing here. It seems like it's supposed to be a library, but I don't understand how that happens. Conan creates this file here automatically as well, or a variation of this, but I also don't understand very well what's the point of the JSON file. Uh, Probably related to CMake. It has to be related to CMake, but I don't understand very well. When should you use it? Maybe the README files explain. Project options is here. But the warnings is just here. Maybe when it does that, it adds the name for the other CMake files to use. Because there is specifying that the project warnings is gonna be a library or I think that is like I'm not really sure though if it specifies a class or not. Because it is not the same language as C or C++, so This is the scripting language that CMake uses, so I'm not really sure exactly what this means. My guess is that it has like is accessing in the same way that you would access the class, like something like that. But I don't get it very well. And targets is another thing that I was kind of confused in the beginning, but targets is just the name of the executable, I think. Where you're gonna put the executable. Yeah, so this is like saying that it's gonna the final product, let's say the final executables are gonna be these ones, I think. But I'm not too sure, like I'm not 100% sure if it's the executable or if it's the library or like the abstract concept of the executable, like the project names, for example, for each one here. I think on the commands, if you put the flag variable when you run CMake, like for the second time after you build the initial setup, when it's time to compile, then you pass the target variable, and then you specify what's gonna be the folder where the executable is gonna be. Yeah, so I think the target's the name of the project from the CMake file, and usually this is gonna be the same as the name of the executable, because you're gonna put the name of the add executable to be the same name as you're using as the project name, but I think not always probably. But it's probably the name of the. I'm not sure now. It can be either way, I think. It could be the name of the projects from the CMake, or the name of the final executables. It probably makes more sense to be the name of the executables. So every time you put this inside of add executable, you're gonna put as target. Maybe this one. Yeah. I know that this readme is gonna be there, but better I should read here, I think. Well, I think that the final one is the other one though. And this one is the one that's still being maintained. So maybe what I should do is just try to run the commands. Close this one, open the other one. I already opened here. So I think I'm gonna copy the project here. I'm gonna go with the not the GUI one, the other one, because it seems like that is more the recent one. Then I can try to build here just to see what happens. I don't understand very well where the GUI code is or what library, if he recommends any library to do the GUI. I think I'll be right back. When I come back, I'm just gonna try to run these commands here on this project to see what happens. I'll be right back. It's interesting that he doesn't run the Conan command first. Let's try to run, see what happens. Hopefully it doesn't break. So the add package commands there, I saw these commands on some of the CMake files there. CPM add package. It's probably something like a environment variable from CMake. Allows you to download stuff. It's probably the presets. So I have to. I'm gonna read the documentation later to understand exactly what's the point of this. The one that's I think Conan does is the CMake user presets. So here is probably, so the preset's probably the configuration on Conan, or maybe not. No, I think it's from CMake. I don't like relying on the GUI. Prefer to do everything on the command line. It's kind of like using straps in the gym. Sometimes it is good because it allows you to push you harder, but then you become dependent on them. So I don't really like that much. Prefer to do everything with the like without gloves and straps. Also, thankfully, it looks like everything worked. There's a bunch of warnings. It's probably nothing that's like there's no recommendation. It's just like the setup that you should use. You're incentivized to use if you're gonna build a GUI project, but it doesn't like he doesn't recommend any library or things like that. So it's something that I should put there. Maybe it's the JSON file name. In the build folder. Instead, if you have CMake, you can use one of the configurations. In the CMake presets JSON file. Yeah, so this is one of these. So I should probably put the name here. But I think since I did the first steps, probably it just went. So like I think there's two different alternatives. One is to just do this command and then it's gonna compile everything with the default compiler you have, which in Windows is probably gonna be MSVC, which is MS Build from Microsoft. And then if you're using Unix, it's probably the Ninja one that it uses. But if you wanna use a different generator, then you just specify the presets, which is gonna be the name here, I think, on the JSON. Maybe I think I'm gonna try that first, see what happens. I have to probably open on the folder, close the project. Okay. I'm gonna try this one. Maybe GCC. Let's go with this one. Yeah, I think that's is that simple. So this file is probably just to specify different configurations you want. Just probably just to make it easier if you wanna like you don't have to remember the commands all the time. If you wanna create one configuration for uh, different compilers. So it's saying that I don't have the ceiling executable. So let's try a different one. I download there, I think, with the Choco now, but it's probably a different one. I don't want to spend time thinking about this. Let me try this one. Just want to see if it works. If it doesn't, I'm just gonna go with the other one. I'm gonna try a bunch of them. So I don't have this on the path. It looks like all of them use this. Well, remember there was a video he talks about this stuff. I think it's because I'm running on PowerShell. So when you run from PowerShell, you don't have access to this CL executable. But if you run from command prompt, you have. But I don't remember very well. Yeah, it looks like I don't. Try on the thing here. But there is a video talks about this. No, it doesn't work. It's probably not gonna work this one as well. So probably these ones require. So maybe I should do the other stuff first and then run this stuff. Because I think it's saying that I don't have the build folder. I'll try a couple of more and then I'll go with the other command. And this one I should have on the on path. And this is the last one that I'm gonna try. But I'm not really sure if I'm supposed to run this after I run this one. Because it's saying instead you have CMake, you can use the other ones. Yeah. So I think it's saying based on here that you can either use this or this. And then you run these commands here. Yeah, but I think this doesn't say anything about the libraries. They're probably not gonna give me too much insights on. Oh, but it's what I'm gonna do is just I want to finish a bunch of these videos first. Then I'm probably just gonna read the documentation on OpenGL and try to see if I can find videos as well from to see which library people recommend to use for creating the user interface if you want to create something with OpenGL. Another thing you can try on the other project is to replace Pragma once with this stuff. There's another thing that he says is that I don't remember exactly well why he says that, but he prefers to use this stuff instead of Pragma once. So oh, this one also I didn't understand very well what it means, but it's pretty much the same as using a macro. So this is like pretty much exactly the same thing. What it does is just replaces the code. Uh, Instead of calling the function, for example, you just copy paste the definition of the function inside of the other function using line. So it's very similar to macros. I don't remember really well like what's the point of using this instead of using a macro. It's probably like some optimization on the compiler, but I don't remember. It's not that complicated. I think I'm gonna stop streaming here and I'm gonna continue to watch the videos there and the courses. It's probably not that much that so I have to study or watch all the videos and then like study the OpenGL documentation, then see if I can find videos of other people building GUI projects with OpenGL to see what kind of library should I use. And I'm probably gonna do it on this thing here. I'm not really sure if I'm gonna use this. Uh, Probably I should use this one. Like if it works now, I'm just gonna use this template to start the project, and then I just put like create a file here Then from whatever library I find, I just read the documentation from the library, then start like try to create a simple function and then just create the GUI. That's probably what I'm gonna do next time. Well, the thing is, like, I don't understand very well this one still. The main thing that I don't understand is why you put these libraries here. So probably I'm gonna delete this one, just an example. This one, I don't know what this stand for. I guess I can just look it up. But I don't know like why do it like this instead of putting everything on the source and compiling everything. So I'm probably just gonna delete this shoe and then just use the. Yeah, but this one doesn't have a CMake. Oh, it has here. I'm probably just gonna use this CMake here. And then I have to replace the names. So instead of a template, I put something else. And I'm probably gonna create several different projects until I know like what to do. Now using the this template's probably better. And I have this stuff for testing in case I want to do that in the future. It looks like it works with the default configuration, just some stuff. It's probably because I have to install something here to make this executable works. It's something related to the tasks. I'm gonna search what this is. See if I can install. Oh, it's PowerShell. It's the command for PowerShell, the cross-platform shell and scripting language. I don't understand why it doesn't work though. I probably need to use. I'm gonna look in the dependencies. Probably need to use the shellcode to install something. It doesn't have anything here. But I don't think it matters that much. It still looks like it did everything. Oh, but maybe not. I think it didn't build. No, this CMake. So it did build. Yeah, so those are the executables, I think. As object files. And this is a library, so it's a different extension. Where is the main executable now? The templates. I guess it just creates the intro executable. Hmm. I guess I have to specify there if I want. So this is probably the main library. So the main executable we create. So probably the way that he recommends you to organize is that put everything inside of this folder here. Like this is gonna be the code. Because that's the only executable that was created there. Failed. Hmm. So maybe it didn't build correctly. I don't understand. It's probably because no, I am on the right directory. Maybe if I use GDB. So maybe it's a problem with the code. I'm not really sure though. Because it wouldn't make sense since I didn't change anything. But I think it's running, it's just during startup program exit. Hmm. Weird. And so now it looks like it does exist. Not sure though. Hmm. Maybe I have to reinitialize this. Not really sure why though. Because like the executable is there, so maybe something else that it was wrong. Alright, now it works. So I think I'm gonna try one more time and then I stop here. And now it seems to be different, I think. The outputs. Oh, okay. Now it runs. So it looks like it is working. Maybe I can try GDB again. So I think the problem is that I didn't have this PWSH, just a way to run PowerShell from my script. So all that I did was ju run choco install, and then I think installed on the path. I just ran the command that they are recommending here on the command line, and then I had to reinitialize. Then seems that it works. But it's still giving this message here, so I'm not really sure. But I think it is working because it didn't show any message on the other one. It seems like it is running the thing, but maybe there is a problem with the code, which would be kind of weird. But it can be because of the compiler, but like it wouldn't make a lot of sense to me because it is supposed to work with all the compilers, I think, since it is like the template and you have a bunch of different options. So I don't see why the code would be wrong. So maybe I did something wrong. 'Cause, yeah, or maybe this is supposed to work like this. It's not giving any warnings about segmentation fault or stuff like that. That's yeah. It's I don't think it's supposed to do this though. During startup, it execute. Maybe if I put this, this is also the thing that's it seems that it is supposed to be this executable that I run because the only one that is creating the folder based on the other folder like here, and obviously there isn't any CPP libraries on the source, so yeah, I think that it is incorrect. It's supposed to show something here. But it's not showing this message either. Or maybe is this message here. So I think that there is something wrong. That problem is gonna take a lot of time. I'm gonna try this one actually. I think it's gonna put on a different file. I'm not sure. I'm gonna try to run this and Regardless of what happens, I'm gonna stop this stream. I forgot the new line here, but whatever. I think only the first time you run is probably this slow. Then the next time it probably caches everything, I think. And then it only recompiles the files you change, probably. It's taking a long time. Yeah, we created a different file. New source. Release. It looks like it runs. It runs, but it didn't output anything. So I think it is wrong. Yeah, there's something going on here. Yeah, I'm gonna stop streaming now. I'm gonna go watch all the other videos. Maybe next time I try to see what's wrong here. Yeah. So I'm not really sure when I'm gonna come back, but probably gonna continue to try to make it happen here. So